Okay, so welcome to our set of notes on metallic bonding. So I'm going to just hide my controls since I know how to do that now. All right, so quick review of what we have done previously. So let's just start. We have talked about ionic bonds, which are between a metal and a nonmetal, or we have a large electronegativity difference. We have covalent bonds, which are between nonmetals only. And we have two different types of covalent bonds. We have polar covalent bonds and nonpolar covalent bonds. And I'll just write that word bonds there and bonds here. And again, ionic is a transfer of those electrons, and covalent is a share of electrons. And a polar bond can give a polar molecule or a nonpolar molecule. Remember, molecule from our previous video is about shape. And nonpolar bonds are always going to just make nonpolar molecules. And again, how do I remember the whole molecule piece? Remember, molecules are a synap, right? Snap those molecules together. Symmetrical, nonpolar, and asymmetrical is polar. Remember, polar means different. A polar bond is between two different nonmetals. A polar molecule is when the distribution of charge is different. It's asymmetrical. All right, so let's talk about metallic bonds. So a metallic bond is a bond formed between two nonmetals or within one metal. And generally, you don't see two metals. You're not going to see a bond between, copper and silver together. So we're really mostly just talking about pure metals here at this level. In upper level chemistry, things can get a little bit more complicated, but at our level, we're just really going to talk about pure metals. And they have what we call a mobile sea of valence electrons. What does mobile mean? It means the electrons have the ability to move. And because they have the ability to move, that means that they are going to be able to conduct electricity. So a metallic bond, right, they have a compact and orderly structure, ductile and malleable. If you remember that from our periodic table unit, ductile means we can draw it into a wire, and malleable means the ability to be shaped. And those moving electrons, right, moving, mobile, allow those positive kernels to slide past each other. And they also have luster, which means those moving electrons reflect light. So luster, a fancy word that means shiny. Metals are shiny, ductile, malleable, and really most important, right, conductivity, right? Those moving electrons carry electric current. When you hear the word current, you might think of like a river or a stream, right? Or a lake or an ocean as current. And what is current? A current has to be movement. In this case, it's those movement of electrons that allow metals to conduct electricity, right? Conduct electricity. And so I want you to make sure that you are aware they conduct electricity also in the solid phase. The only thing that can conduct electricity in the solid phase is going to be a pure metal. So remember, your ionic bonds, right, when they dissolve in water, they split into ions. And let me just jot that down over here. So ionic bonds, just as a quick review to throw that in there, dissolve in water. And so that what we make an aqueous solution. So solution, S-O-L-U-T-I-O-N. And those conduct electricity as an aqueous solution or in the liquid phase. And then that's not because of mobile electrons, that is because of mobile ions, right? Those charged particles are free to move. So if you see something that conducts electricity as a solid, that's telling you metallic bonds. If something does not conduct as a solid, but does conduct as a liquid or as an aqueous solution, that is telling you that we have a ionic bond. So now what is an alloy? So an alloy is a mixture of two or more elements, and one of which has to be a metal. And so the purpose of making an alloy is to have a superior composition than the individual elements by themselves. So an alloy has superior or better individual than its individual components, the physical properties or chemical properties. And in some cases, it's going to make something stronger. So an example of an alloy, we have brass is an alloy, right? You've seen, brass fixtures and things like that. Brass is an alloy between copper and zinc. We have bronze, right? The whole, I don't know, maybe you learned this in history, right? We have the whole Bronze Age, right? Because we have this alloy between copper, zinc, and tin, right? Which allowed for all sorts of neat advances in, technology available, right? So that's some examples of some bronze. And now we have cast iron, which is not the same thing as just pure iron. Cast iron is a mixture of iron and carbon, right? So cast iron cookware, right? Conducts heat really well, retains heat really well, very durable, great, excellent cooking. I love my cast iron pans. We have sterling silver, which is a mixture of silver and copper. All right, so then that's going to sum up our alloys. And remember, alloys are mixtures. And so let's ask ourselves, are these heterogeneous or are these homogeneous mixtures? Stainless steel is another example of a really good alloy. And so stainless steel, obviously it has some antimicrobial properties, and it has it's pretty strong and it's great stuff. We use a lot of stainless steel. I really like stainless steel. All right, so alloys are going to be homogeneous mixtures, right? Because it has an even distribution of particles, right? So in this brass over here, I don't see, individual copper, and I don't see individual zinc atoms. I really see just in the same thing with this cast iron, I can't see what's the carbon, what's the iron, right? Because it's a homogeneous mixture. It has an even distribution of particles. So I'm just throwing in some review from the earlier in the year. So even distribution of particles. And a mixture, the proportions can vary. That means that the proportions can change, right? So a gold ring is actually not 100% gold, right? There's different proportions, which was, how you get different carats of gold, because there's different proportions in that alloy of gold, right? So a proportion can vary. In a chemical compound, the proportions are fixed, right? Because mixtures and compounds are opposite. Homogeneous, heterogeneous are opposite, right? So a heterogeneous would be an uneven distribution of particles. All right, so main takeaway, metallic bond, pure metal. We're also, let me just quickly go back. This is going to take me a bit. Hold on. I want to just do one more property over here. We're going to have a high melting point. So high melting point and high boiling point as well. Okay, so which is similar to ionic, but not the same as ionic. But we do have a high melting point and high boiling point, right? Metals it takes a lot of energy to melt or boil a metal. So in our next set of notes, we'll talk about intermolecular attractions or intermolecular forces. And thank you for listening. Until our next set of videos. Bye.